So see here, we are having a 2D array intervals having start time and end time of intervals. Now let's create the method schedule and let's pass this intervals array. This method will return maximum set of intervals that has no overlaps. So we will collect the data in list of integer arrays. So let's call it optimal schedule. Now let's create this method schedule. And here let's initialize a list that will hold the result to be returned by the schedule method. So it's a list of integer arrays, optimal interval set, it's a new array list, and it's a list having integer arrays in it. Let's import array list. So after initializing this list, the first thing that we are going to do is sorting the interval according to their finish time, as we want to have the maximum number of intervals. So sort, let's import arrays and let's pass the intervals and let's pass an implementation to the comparator as we want our own implementation. So here let's implement the compare method for the comparison. So let's first import the comparator and then let's override the method. So we want to sort according to the finish time. So O1, and the finish time is present at 1th index. At 0th we are having start time. At first index we are having the finish time. So it is O1 1 minus O2 1. So this will sort in ascending order. And how the sorting is going to get us maximum number of intervals. See the 2D array intervals. The first interval is having n time 3, the second is having n time 15, and the third is having n time 10. Now ignore the start time and see the n times. If we don't do this sorting, then it might pick the second interval, which is covering more space. That means we would be able to have less number of intervals in the solution. So the sorting is important. Now after sorting the intervals according to n times, now let's take a variable last finish time and set it to the minimum value of integer. So we are initializing it with the minimum value. And then we're gonna take a for loop to iterate through each and every interval. So for each interval array present in intervals, this is interval array present in the intervals list, initialize a variable start with interval 0, that is the start time for that interval. So this is the start time for that interval, and now we're gonna check if this is the start time. Now we're gonna check if the star is greater than the last finish time. That means it must not overlap the previous included interval, right? So that's why we're checking if the start is greater than last finish time. Then we're gonna get the end, which is present at the 1th index, at the first index. So let's, after taking this end, we are going to add this interval to our optimal interval set because we are going to pick it. interval. Now, as we're including this interval, I have pronounced it wrong, I guess. Okay. Now, as we are going to include this interval set. So as we're going to include this interval, we are going to update the last finish time. So last finish time is this end. So again, it is going to go in this loop and again going to check if the next start is greater than the last finish time or not. And in this order, it will get us all the intervals in this optimal interval set. And finally, we will return the set. Not, let's copy this and paste this. Okay. Oh. So the implementation is now complete, and now we are going to go back to the main method, and here we're going to print the result. So let's take a for each integer array present in this optimal schedule. Let's print out the result, the start and end intervals. So this is dot length sys out is I. So it is going to print the start and the end of that interval, and after each interval, let's give a line. So now the implementation is complete. Let's run this and see the intervals we get. So these are the 4 intervals that we got using this greedy technique. So it is ending at 3, next is starting at 5, and 10, 12, 14, 16. So no one is overlapping.